This chocolate elephant. The winner will be announced at the end of the day. Now, please meet Valery Kosarev. Valery Kosarev. Good afternoon. I represent Red company. This is a system integrator. We operate in various industries like communication, heavy industry. We offer communication solutions, and we do take part in public purchases, public contracts. I actually am the head of a big department dealing with databases, and I work with Postgres for quite a long time already. I would like to tell you about one of the cases that we've been through. We were offering solutions for this case. First few words about where it comes from, a short history of the question. I usually use simple schemes to show all the solutions related to databases. To us, it is interesting that at a certain moment of time, we started using blobs by TR array in Postgres, binary data that are stored in tables in a DB. Maybe because of the insufficient quality of architecture. And actually the case that I'm going to tell you about was inherited by us, so it has a history before we stepped in. So it all ended in a situation when we started actively using these opportunities, and we started putting documents into binary blobs, and our blobs at some point were taking over 90% of the overall DB volume. 90, actually, this is an indicative figure, and at some instances it was up to 98. In fact, I think you can imagine how difficult it is, because they are a static content. You don't have to do anything to it. You write it once and you only read it after that. You don't have to do anything with it. But at the same time, this is quite an expensive resource. And you need to spend a very expensive resource. And I know that you know the procedure of backup, vacuum, that has to be applied to this kind of content. But in fact, this specific type of content does not need these backup and vacuum procedures. And we end up with a sad situation. This sad phase represents our users and administrators that sometimes really were short of time to perform daily backups during the specified technical window. Now, how could we view a right solution applied to this type of data? Probably the static content should be stored not in a database, but in a system for storing content. The database ends up with being small and compact, and the transition would be simple and clear, and everyone should be happy, it seems. However, the problem, in our case, that was the source of the problem, is that the application was developed a long time ago, and it was not easy to instantaneously perform refactoring, and at the same time we would like it to be getting the data we needed from the database, in the reality the data would be stored not in the database. So we decided to write a small extension on Postgres because there is such a possibility at Postgres. This is the name of our extension. And actually, this extension was appointed to deliver the content, and the application would then think that the content is stored not in that storage but in the database. As we are taught at AP courses, and here this is a bit of advertisement, there we actually teach people how to create extensions, and here we created a new type of data inside Postgres. ByT is the existing type of data, and RByT, it means that this data are stored somewhere else. This is a compact type of data, only 28 bytes long, and this is just the header of the data, and the data themselves, they are stored there where this header points to. Here is a part of SQL file. The procedure that transforms RByT to byte and back. At the top you have an example of clone functions. The matter is that we created our type of data in a way that the data that were once stored in the storage, they may be referred to from various places of the database. Sometimes it is not very convenient to do that, and sometimes we need to clone them, and this is what this function is for. We also had to apply to use one of the possibilities Postgres gives to create our own indexes and to implement them in this way. Why did we have to do that? It is not an easily implementable thing. In fact, external storage, it does not have the same transactional capacities compared to a DB. And here, in fact, we started running across obstacles, and we came up with the following. Maybe some would think it bizarre, but at the moment where we process using the access method, the index, when we process changing in tables using the indexes, we are rolling back or we are fixing the transaction to the external storage. This is a good method. However, please do not think that this is a reproach to Postgres developers, but it is somewhat incomplete. In some operations of creating an entry or vacuuming entries, and we usually correctly clean everything and correctly adjust the statuses, but unfortunately in this beautiful system of supporting indexes there is no possibility to insert your function when you delete entries. When vacuuming it is possible, for deleting entries it is not possible. Maybe there is reason for that, but actually that made the situation more difficult for us. Part of announcement on C language. In brief, this header that creates data in the volume of 20 bytes, this is a type of storage, some flags, and then the identificator. As the identificator was selected, this type and it is generated inside one of the Postgres extensions. We made our extension dependent on that one. And then we use three constants to identify three types of external storages that we're going to talk about today. One of them is implemented almost in full. The other two are under development. The first is Ceph, and later on I will have one slide about what that is. There is a local file system, not the one inside tables, and type number 3 is the one that stores data inside the table, and then the type of data is identified in the end of the table in the column. This is needed for seamless transition from one solution to another one when initially we create a column with a new type and the data are still stored in the old one. And the new type refers to the old column, but then data are consequently transited to the new type, and that is how migration is performed. It can take a long time, weeks or even months, but during all that time the application would think that the data are stored in the DB. As an example of what this type of data could be, here we presented a part of the results of regression tests within our extension. It is just to demonstrate that there are some attributes in the relation related to Ceph. We have client ID, username, if we're talking about Ceph, and select number 2. It actually shows, well, you can see a part of binary data here, but if you look to the bottom, you can see field and data there, and the identificator, and then it is followed by flags, types, xmin, xmax, as you might guess, many of you. Speaking about transactional completeness, we need to actually use this type of attribute. And if the transaction is committed, and it received a number, Xmax will get the information about when these data were deleted from the storage. At this slide you can see part of PGConf. We added these parameters here, taking them from Redis library that are implemented by API Ceph. API, in fact, have Ceph have a very good library in API, and there are parameters here that are related to instance Ceph, what user we should use to reach it. There are abstracts of the pool of data, and here you can see the main pools, repository pools, and in fact we do not delete the data directly from the basket. We send it to the repository, and then we delete it from the repository. In fact, there are other technical parameters, but they are not very relevant right now. After we transited all the data to the external storage, the only thing we need from this new type is the identificator. This UID that we are going to send to this application that will be refactored and that will take the data in a normal way from the storage.
With the help of database, as it is shown schematically on the picture, And the link between database and storage can be preserved for some time in a system. But its essence, the primary essence, is temporary. That means after the migration is performed, we can delete the extension and put an end to this whole procedure of migration. This is the slide that I was speaking about. What is Ceph? Ceph is this distributed storage system designed for excellent performance, reliability, and scalability. You can also get information about the license. There are many papers. The pool of literature is broad. It's a bit strange that this Ceph is not in the top of discussions on thematical resources, but still we use this storage as a huge data storage for one state structure, and we are happy with the experience with Ceph. It's not only petabyte structure, but it can be also scaled. You just can add some machines, some disks, and the disks can be various, the slow ones, the rapid ones. Everything is reliable, understandable, and feasible. So you can take a closer look at the information. Of course, there are limitations and risks. As I already told you, that Ceph is practically realized. Our extension is operating, but speaking about local file system and the data in the same line, these parts are not developed yet, but still we are planning to develop them. The compatibility with Postgres SQL is made for 9.6, but now we're in the process of testing for 10. There are many versions for test, but still, after the tests, we can see that the quality of libraries and readers are the only thing that we can rely on for us to get rid of leaks. And if we are working inside of the Postgres, when we're writing by ourselves, we use P3 or Pollock. Ceph doesn't know about this. They are using the standard system calls to assign memory, but this can lead to memory leakages inside of the Rados library. And our experience of migration is for now realized. That means we've migrated to Ceph, and it also means that we did not wait for several weeks or a month. We've just had a technological window to perform this in 2 days, at the weekend. So the vacuum, what do I mean by vacuum? First, we tried to directly clean up the data in the distributed storage, in the external storage, but it's not possible in 100% of cases. Later on, we came up with the idea to write the procedure vacuum for external storage, but for now it is not made, and we were thinking about it because the volumes are too high. These are petabyte storage, and it's not easy to go through such vacuum, to use vacuum for such kind of storage. Perhaps we will be forced to do this. You can see my data on GitHub in the sources. Thank you very much. If you have some questions, please feel free to ask them. Thank you very much. It was very interesting to listen to your story. How can you fight with huge binary data? There was a method of cloning on one of your slides, along with the counter for links. It's interesting to know whether you have a method of deduplication, or have you thought the application can borrow this data. During the realization, we've made this possibility active, and as I already told you, we can choose clone or choose select from and assign the place, but the data won't be multiplied. We're only making a copy of the link. So the data will be in the external storage, and inside of the database you will see on the you can read it. But if you write down the information into storage from somewhere else, yes, through bypass, from R byte to R byte, from one table to the other table, we're not dubbing the data, we're not copying the data. But if you need this data to be cloned, there is a separate function, clone. And the counter, therefore we're using the counter, because we're just only trying not to break, not to lose data. We're counting the places interfering with this data. And when we go to the 0, we are making archive of the data. Igor Mozersky. I have two questions. First, what is the response time compared with the time when you worked with the data in database? Now everything is in the cloud, but not in the database. Actually, it happened that the bottleneck was the network for us. So the application works, operates, and the database is somewhere, but not so far away. The file system was more rapid than the network. And when we migrated to Ceph, and you need to take into account that Ceph is providing possibility to create more nodes than in the regular file system. Therefore, our bottleneck was the network, and we did not see any fall, but in the frames of the limitations of network. But what about your data, your big data, text data or binary data, PDFs? There are no operations performed with them. Either you take them or lay them. This is the key note. Why don't you use Clowder HBase or something like this? But it will be in table space and bars data. Yes, but it will be distributed database, distributed storage system that is rapidly working. Yes, we can create distributed storage, distributed database like this, but we also can use shardings. So you did not think about it. Okay, thank you. Thank you for your presentation, Vladimir Pravoru. What is the backup that you are making in the Ceph? Or do you work only with replication? We were thinking that Ceph is working more rapidly, and we have also proofs for this. These are the files, the same file systems, but there are several of them. And the network also affects this, because if network is bottlenecked, they will be the same. And the second question, is that we are trusting to the Ceph, and if we've adjusted the system correctly, we will not need to make a backup of the system. My name is Andrei, Plugable company. Thank you very much. My question is, what happens when Ceph is down? What happens with the new files? What happens with the context? So Ceph is a reliable system. It's scalable, also up to the monitors. But if we don't have access to Ceph, and if it is impossible to write down, it will be the same situation, the same exception. Exception will pop up like in Postgres. You just trace it, and that's all. Grigory Smolkin, PGConf. My question is, if you will need to restore Postgres from backup, if you have seen some logical mistake in your database and want to roll back 24 hours, will the consistency be distorted? Yes. You just need to take a look at the identifiers, whether they are in your database, and theoretically you can encounter the loss of information, or it will be more information than you will have it. That means that you will then sort out the database, the data storage. In the end, you will still need to apply vacuum. There will a time come when we will go through all the nodes, through all the headers in the storage, and compare it to the information that we have in database. And the last question, please. Victor Istomin. If there is enormous quantity of small files in your storage, like trillions of them, we're not especially fighting against this, because Ceph tells us that Ceph will manage this, and Postgres will also manage this situation, so we're not making anything special. Do you think there will be some issues? And the last question, please, though. I have the second question. Suppose that there is a PDF in Ceph and the user renew this PDF. Will it be the new file, or will we replace the old file? It all depends on what the user did. The user updated the PDF. If it's just a regular update, or please describe the situation. So there was one state and you passed to the other state. If there is a volume of entrance, nothing happens. So the document was changed. If the document is changed and you want to store the new document, you are just using the new binary data, and it will be the new element of storage. That means you will swell, but so in the moment of update, xmin, xmax, as I already told you, the new data will be added in front of the old ones. It will be installed into transaction that made the update, and the vacuum procedure will go through it and will delete the old document. So my first question was about backup and restore of the last 24 hours. That means we will still lose the data, the user data. Yes, there is one non-solved question, because we are not deleting the data. We are just transferring the data to the archive pool. To the repository pool. So we have the repository pool with data of the last 2 years. We can kill this pool, but still, perhaps for some cases like this, we could use it. Yes, I think you will use it. Thank you very much. Thank you, Valery. And we're having coffee break.